Okay, we just learned the product rule. If you remember, if a product of f g, take the derivative, it's going to be f prime g plus f g prime. Or you can change the order. You can say f g prime plus g f prime. It's the same thing because it's just a plus, so you can just switch them. But today we're going to learn what is f over g prime. Okay, so let me see. Um, Derivative of f of x over g of x. This derivative should be, it's a little bit complicated. When I write it, you're going to see how scary it is. So it's a limit delta x approach to 0, and the top here is f of x plus delta x over g of x plus delta x minus f of x over g of x over delta x. Are you scared already? Because they have a fractions and a fractions again, okay? So don't worry, we learned so many things, so we just keep doing it. So we use everything we learned before. Delta x approach to 0. The top, you can find the least common denominator, which happen to be the product of these two. And then that will be g x plus delta x times the g of x, and the denominator is not changing, okay? And then this you multiply, you get this least common denominator, then you have to multiply by g of x up here. So it's going to be f of x plus delta x g of x minus f of x g of x plus delta x. Okay, you see what I'm doing here? So far, so good. All right, now I get the limit delta x approach to 0. I bring this down because that's the denominator. So that is the delta x g x plus the delta x g of x. And then this is the numerator, but it seems like there's really nothing we can cancel if we just keep it like that. So I'm going to, again, add a term minus a term just like what we did earlier. So I'm going to add, so far I just copy the first term. Okay, I'm going to add and subtract at the same term. So I minus f of x g of x, and then I go plus f of x g of x, and then minus f of x g x plus delta x. Okay, now I combine the first two terms. That will be the limit delta x approach to 0, and the bottom is delta x g x plus delta x g x, and the first two terms I get out the g, so I have f of x plus delta x, right? Subtract f of x, okay? This times the g of x plus, and the later two terms I take out f of x, and inside I will have g of x minus g x plus delta x. Okay. Well, of course you can see, oh, that we usually get used to like an x plus delta x term minus the other ones. You can change the sign here. So that would be the limit delta x approach to 0. Did you notice that this f, let me just write it, f of x plus delta x minus f of x times g of x over, and the bottom is delta x g x plus delta x g of x. And then I change this sign to be minus. Then I write limit delta x approach to 0. I change the order. So I have an f of x, and then inside I have a g of x plus delta x minus g of x over delta x g x plus delta x g of x. Whew. All right, now finally I get to something that looks familiar. So f of x plus delta x minus x over x. Is that an f prime? So that is the f prime x, and the top is g of x. Now the denominator, when delta x approach to 0, the denominator is g of x squared. And then I go minus, and the top again, this delta already worked with that, okay? So g of x plus delta x minus g of x over delta x when delta x approach to 0. So that will be just g prime x. And then down here, again, it's a g x squared. Okay, so that is your formula. Now, if I write it in another easy way, I like to use an easy way. So f over g prime is going to be g squared, and the top is f prime g minus f g prime. Now, this order matters because this you're going to take the derivative of the numerator first, because that's a positive term, multiply by the denominator. Then you minus, copy the numerator, and then take the derivative of the denominator. And don't forget, here's a negative sign. So this is called the quotient rule for derivative. All right, keep this in mind. Keep this in mind. I keep that at the bottom of the page, and then we're going to work on some exercise or some examples. You're going to see how do we work on that. Okay, so let me see. I give you a function y equals, get this, x cube plus 5x over 15x, and we change that, minus 1. How do you get the derivative of this? Now, this is your f, that's your f. You don't have to write it, okay? But you should really know this by heart. And the g of x will be just 15x minus 1, isn't it? Now, what is f prime? If you take the derivative of this, you get 3x squared plus 5, isn't it? And what is your g prime? G prime will be just a 15. Okay, so, and what about g of x squared? That is a 15x minus 1 squared, which is 225x squared minus a 30x plus 1. All right, we know everything, so just by looking at this formula, f over g prime, so that y prime should be, the numerator is f prime g times f g prime, so f prime, we know, 3x squared plus 5 times g, 15x minus 1, minus f x cubed plus 5x times g prime, which is 15, okay, and the denominator is 15x minus 1 squared. Okay, you can use the distributive property to simplify this, and you can get the answer. So I just take very quick time. The denominator, you can just leave it like that because we don't know. We might be able to simplify this later. We don't know yet, so I just keep it. And the denominator, if you keep it this way, that is fine. So the numerator, we use the distributive property FOIL. So I get a 45x to the third minus a 3x squared plus 75, because 5 times 15, 75x minus 5. Go ahead. Minus 15x to the third minus 75x. You agree? All right, now go ahead. I have a 45 minus 15, that's a 30x to the third. The square term minus a 3x squared. And the interesting part is this is 75x minus 75x can't cancel. So I get this minus 5. and then 15x minus 1 square. All right. Do you think you can simplify this? We don't know. If you like, oh, it's like I think I can just use like a quick review for this. 30x cubed minus 3x squared, and then leave the blank for the x term minus 1. You divide it by 15x minus 1 to see whether you need to simplify that. So 30x cubed, 15x, you should have 2x squared, right? So 2x squared times 15, you get a 30x cubed minus 2x squared, and then subtract this minus that, you get a negative x squared. So then this one you should have negative 1 over 15x. So until now you don't need to go any further. So that would be your answer. Okay. So this one is forget about that, and then so you're okay. If you're not familiar with this, let's see, is there anything you can do? I think you probably want to go to like a long time ago when you do like a algebra, they do the long division. One polynomial divided by another one with a lower degree, then you can just go there. Because otherwise, then you can leave it like this, and then most of the time it's going to be just like that. Okay, so this is one example. Let me give you another example here. Give you y equals this. Because I really want to do some sine cosine stuff with you. Okay. So what about this one? What about tangent? Can you find the tangent x prime? Let me write it that way. Tangent is a sine x over cosine x. You agree? Ha, that is the derivative, right? So the top f of x is a sine x. So f prime x, we know that is cosine x. And our denominator g of x is cosine x. And g prime, which is a negative sine. Okay? So y prime equals, first of all, denominator square, which is a cosine x squared. You agree? And the numerator, we have to take the numerator with derivative of that, which is a cosine x times the denominator minus the derivative of the denominator, which is negative sine x, times the numerator, times the denominator, times the numerator. Okay. Interesting. So we're gonna have here we get a cosine x squared, and the numerator. Look, I got a cosine x squared. I go plus sine x squared. Did you realize that is just a 1? So that is 1 over cosine x squared. Okay. Or, of course, you can write as the secant square x. Okay, now we learned tangent x prime is secant square x. Interesting? It's interesting, isn't it? Yeah. Okay, so that let me just write it because we use the quotient rule to find the derivative of this tangent, the derivative of a tangent. That's very interesting. Okay, so what about another example? Y equals, let's see, top 1 minus cosine x over sine x. Okay. Or, yeah, I think that's it. So that we have f of x equals 1 minus cosine x. So f prime of x will be the derivative of 1 is 0, and the cosine derivative is negative sign. And there's another negative, so that will be the sign, right? And then the g, the denominator, which is the sine x. So g prime is cosine x. So y prime here equals the denominator square, sine square, and then derivative of the numerator, which is the sine x, times denominator minus numerator times the derivative of the denominator. Okay, and that is, okay, we have sine square. Here I have a sine square. All right, now distribute this. I got a negative cosine x. And then this cosine, cosine, that's cosine square, negative, negative, I get a plus cosine square x. Now these two add up to 1, so my answer is this, is 1 minus cosine x over sine square x. Okay. If you want, you can simplify this because let me just do, let me keep doing that. I tell you. Okay, so it's 1 minus cosine. Sine square is 1 minus cosine square x, and you can factor the denominator becomes 1 plus cosine x and 1 minus cosine x. And the numerator is 1 minus cosine x. And that answer will be just 1 over 1 plus cosine x. Okay, so either way, you give me this, you give me this, that's okay. You give me this, that's okay too. Okay, I think that's what we need to learn for this quotient rule. And just a quick review, if you have f over g derivative, then it's going to be g square, and then the top is f prime g minus f g prime. So that was the order matters right now because here is minus. And the other one we learned f g prime, that is f prime g plus f g prime. For this one, it doesn't matter which one you want to do first. This is the product rule, this is the quotient rule. Okay, so that's all for this quotient rule.